Okay, so today we are going to talk about geometries. So these different shapes of molecules and covalent pairs. We're going to take notes from the picture. This picture is within the lesson Covalent Bonds Lesson 3, Lewis Structures, and this is day 2. So you should have already done Lewis Structures, practice Lewis Structures, and then we are going to talk about these geometries. So today's notes are kind of from the picture that you have here. So let's pull in our notes. I am going to label them Covalent Bonds 3 so that we know what lesson this comes from. So we have 2 sets of notes from one lesson. It is what it is. All right, and this set is going to be called Geometries. When you think of the word geometry, what do you think of? Shapes, yeah. So these are shapes of molecules. Right. Shapes can be determined by lots of different things. But if you think about the shapes that you know, like triangles, squares, rectangles, a lot of it has to do with how many sides. The shapes of molecules are going to have a lot to do with how many things are attached to the central molecule. And so before we get to the actual shapes, we have one kind of important piece of information about the shapes. We're dealing with electrons. And what do electrons do? Electrons are all negative. So are they going to attract each other or repel each other? They're going to repel each other. That's really important for understanding geometries. And so the other day we talked about unshared pairs when we had, when did we do that? Hold on just a second. Sorry. The other day we talked about unshared pairs, right, of electrons. And we kind of talked about how they push a little bit. Well, the unshared pairs have the strongest repulsion. So we're going to write that down in our notes right now. So 2 unshared pairs repel the most. And we'll talk about what that really means, but if you think, okay, there's 4 electrons pushing against each other. That's a lot of negative to negative repulsion. And then unshared pairs right next to a bonding pair of electrons have a middle level. So not good English, but we're going to write repel in the middle. And so that leaves a bonding pair right next to a bonding pair. Have the weakest repulsion. Okay. So if you were to visualize the strength of repulsion, you would have unshared to unshared is the strongest. Strongest. It's the greatest. So we'll do a greater than sign. And then unshared to bonding. And this is going to make a lot of difference when we talk about these geometries. Unshared to bonding in the middle. So just like we wrote, even though it wasn't the best English. And then the weakest repulsion is bonding to bonding electrons. So we'll go through those as we move along through these different shapes and geometries. So the first shape that we're going to talk about is called linear. Okay, so Mr. Obvious moment. If it's called linear, what is it going to look like? A line, right? So let's look at the picture that we're given. Okay, super important part about these geometries is you need to know, and I'm telling you this because there are questions on the test about this, but you need to know the angle. So a linear molecule has a 180-degree angle. What's the angle of a straight line? 180 degrees, right? Like if I have a straight line and the pivot point's right here, you would tell me that was 180 degrees. So we might just note that to help you remember. Because you already learned this in math, right? Of course you did. All right, so let's make some observations. If we look at the linear model right here, we have a central atom. We have two things on either side. So that's actually how we're going to remember this. Two things around a central atom. And linear is kind of the most simple one because they just want to be these things around the central atom just want to be as far away from each other as possible, right? So let's move on to the next one. Next one is trigonal planar. Break down that word. What does tri mean? 3. Okay, so trigonal, we know that has to do with 3. And then what is a plane? Not the thing that flies in the air. But if I have the plane that I'm looking at, or if I plane wood, I make it really flat on one side, right? So 3 things that are flat is basically what this means. And we'll kind of look at this with this picture. We can see in our picture, it's 120 degrees. If I'm looking at the picture that's right there, these things kind of lay flat all the way around the central atom. How many degrees are in a circle? 360, right? So if I take 360 divided by 3, what do I get? 120. So the angle right here is 120 because I'm taking 360 divided by the 3 things, my 120, right? And so we could go ahead and write 3 things around a central atom. So that one's a little more complicated. So let's draw a picture, all right? If I have my central atom, I'm going to have things pretty well evenly distributed. So this angle right here is 120. Okay. Or it just says things, right? We could also have our central atom right here. We could have 2 atoms off of it and an unshared pair. Okay. This is called bent. And it's bent from the trigonal planar model. Right? So we're going to bring in that original statement that we made. 2 unshared pairs repel the most. Unshared to bonding repel in the middle. And bonding to bonding electrons are the weakest repulsion. So when I look at this bent model, these unshared pairs here are going to push the bonding electrons down. Right? So this angle right here is going to be less than 120 degrees by a little bit. Probably around 118 degrees. Okay? Because this unshared pair is going to push the bonds away. So we'll go ahead and make a note of that. Pushes the bonds away. All right. So then our next shape is called tetrahedral. What does tetra mean? When we talk about our prefixes, it means 4, right? You can't do that. Okay, so tetrahedral is 4 things around a central atom. We can see from our picture here in the lesson that it is 109.5 degrees when there are 4 atoms. Okay. So we have our central atom, and we have all evenly spaced out because these bonding electrons push each other all the same strength. I guess we should make a note because my drawing is terrible. Evenly spaced out at 109.5 degrees. But what if one of these is an unshared pair? What did we see up here? That unshared pair is going to push the bonding electrons away a little bit. So we got an or we could have our central atom, 3 things, and our unshared pair. So this unshared pair is going to push them down, and our angle here and here is going to be like 107. This shape is called pyramidal. Why do you think it's called pyramidal? Well, if I draw a pyramid, what am I going to draw? Right? So these 3 bonding angles are right here. It's just we don't have that part. And then your unshared pairs would be at the top. So it's actually the shape of a pyramid. We have one more or for this one. And this is a pretty important or. Or, what if I have my central atom and I have 2 unshared pairs? Uh-oh. Let's go back to what we know. 2 unshared pairs repel the most. So these guys are going to push on each other this way, and they're going to push down on the bond, on the bonding electrons. That's going to give us an angle of 105 degrees, about. Okay. Now here's the part that you might just want to sigh loudly for. This one is also called bent. But it is bent from the tetrahedral shape. So you have to be kind of careful in this. There's 2 bent. Bent and bent. If you only have 3 things, so 2 atoms and an unshared pair, it's bent. The angle is greater than if you have 2 unshared pairs. Okay. So you're going to have to differentiate those two. The biggest, most important example of this one is water. So if we look at the Lewis structure of water, we have 1, 2, 3, 4, 5, 6. See, look, there's my unshared pairs. And then my hydrogen, we've got a bond there. So you will be asked, what is the angle of the water molecule? And your answer will be 105 degrees. Because between the bonds, it is 105. All right. Give me a thumbs up if that made any kind of sense. All right. So I'm going to stop recording, and then we'll go through some of the work problems.